Hello class, so this is a part 3. Now let us continue to look at them together. So we have an equation of tangent to the graph here. Now at the origin here we realize that the value is 0, comma 0. Now what is the derivative of arctangent? In fact, that would be equal to 1 over 1 plus that value square, which is x over 3 square multiplied by derivative of inside, which is equal to 1 over 3. Now when the value of x is going in here, we realize that this portion simply becomes 1, therefore slope becomes 1/3. Now, if slope is 1/3, then our equation becomes y equals simply x over 3. Now anything that's similar to that would have been choice A, so A becomes our answer. Alright, now the next one. Here we have from 0 through 3. Then what's going to be happening between 0 through 3? Now 0 through 3, we realize 0 and 1 is based upon this one. The rest of them will be this. So in other words, we're going to get 0 through 1 for x squared plus 4 dx plus 1 through 3. We have to separate this one into two different intervals, minus x dx. Now, then here we have x cubed over 3 plus 4x, which goes from 0 through 1, plus here we have 6x minus x squared over 2 for 1 through 3. Now here we have this portion can easily see the 1/3 plus 4, so 1/3 plus 4. And in this case, when you plug in 0 for both of them will be equal to 0. Now, plus if you plug in 3 here, we end up getting 18. And then here, minus 9 over 2. When you plug in 1 inside, we end up getting 6. And then minus 1/2. Now, when you finish everything, we end up getting this one is 4/22. And when we add up everything, in fact, you will realize here that this is 4. Negative, negative becomes positive, so 4.5 with a minus 4.5. Those two things will cancel out. And we have 18 minus 6 becomes 12, but adding 1/3, it's going to be a little bit more than 12, so our closest answer will be between 10 to 15. Now the next question. Here, a tricky thing here is this portion. Right over there. ln of e, in fact, that's equal to 1. In other words, this portion becomes 3x times ln of e. But ln of e is equal to 1, so therefore, this is the same as taking the derivative of 3x against the variable x, which is simply equal to 3. Therefore, our answer will be choice B. Alright, now next, on acceleration, it's given in this way. If t equals 1, that's our key point right here. Velocity is 4 and position is 6. And then t equals 2, or is a position. Now, then that means we need to go backwards, where since a is equal to 3t plus 2, what is v? v is equal to 3t squared over 2 plus 2t plus c. Now, when t is equal to 1, v was equal to 4. So then v was equal to 4. When t was equal to 1, then we realize that we have 3 over 2 plus 2 plus c. Now, when you simplify this one, then you will realize that c here is equal to 1.5. 2 becomes 3.5, so we end up getting 1/2. C becomes 1/2 when you calculate this one. Now, that means this can be rewritten as 3t squared over 2 plus 2t plus 1/2. Now, when you go for the position, now we have, take the another antiderivative, we end up getting t cubed over 2 plus 2, plus t squared plus 1/2 t plus c. Now, Here, when you plug in 1, you end up getting 6. So 6 equals 1/2 plus 1 plus 1/2 plus c. Now, then here we realize that c has to be equal to 4. That means x is equal to t cubed over 2 plus t squared plus 1/2 t plus 4. Now, we're looking at when time is equal to 2, and as you plug in 2 for all of them, we end up getting position x becomes 8 over 2 plus 4 plus 1/2 times 2 plus 4. Now, then here it simplifies into 4 plus 4, 4 plus 4 plus 1 plus 4. Then we end up getting 13 as our answer. Now, it should be right over here. The next question. Now, this is the distance versus time graph according to the graph. In what time is the interval, is the speed of the leaf the greatest? Speed here, in fact, talking about the absolute value. That means as long as it is steepest, it will be okay. In fact, you will realize the steepest around this section. So 3 through 5. The answer has to be choice B. Alright, now this portion is the calculator part. So, oh no, actually not yet. Soon after. Water is flowing into the tank with 6-foot radius. Now, then here, if I were to sketch the diagram, we end up getting here. Now with the radius is equal to 6, and then the constant rate of 30 pi cubic per. Now, so this portion becomes dv dt, and now the volume of water in the tank is given by this way. Now, what is the rate at which the depth of water in the sink is decreasing or increasing at the moment when water is 2 feet deep? So in fact, we realize that when h is equal to 2, so we have to take the derivative of this one, right? Now, then we realize v prime is equal to, we have to use the product rule here because we have two h's in 2 locations. Now, or we can simply multiply everything out. Let's try to go for that first step. How about this one? We'll do that a little later. When you rewrite this one, we'll end up getting v is equal to pi h squared over 3 times 18 minus pi h cubed over 3. Now, here we get 6. Right, so when you take the derivative, v prime, here we end up getting 12, because 2 from here and then 6 was already there. 12 pi h times h prime. Minus here, 3 comes out, cancels out with the bottom, pi h squared times h prime. Now, here we realize this portion was equal to 30 pi equals 12 pi times h was equal to 2 h prime plus, oops, minus, here h was equal to 2, so pi times 2 squared h prime. Now, then you will realize that the h, after much calculation, then this becomes 24, and subtracting 4 becomes 20. So hence we end up getting 10 feet, actually, have we made a small small mistake here somewhere. Alright, we made a slight mistake right over here. Sorry about that. When you calculate this one, we end up getting 30 pi is equal to 20 pi h prime. So therefore h prime becomes 1.5. So we end up getting right here. Let's go for the next. Now, so this has to be increasing. Now, in order for us to look into this one, we have to look at this one for a second. We realize if you have to simplify this one, increasing them is f prime is what we're looking at. So here, similar, same as before, 2 times 5 over 3 is multiplied, and then x to the subtracting 1 from there, we have 2/3. Minus here, we end up getting 10 over 3 x to the negative 1/3. Now, this one has to be equal to 0 to determine what's going on. Now, then in this particular case, since if I were to rewrite it, 10 over 3 x to 2/3 minus 10 over 3 1 over cube root of x, same way here, is equal to 0. But since the coefficient is the common, if you're to factor out 10 over 3, then we end up getting this one, x squared, but cube root of x squared minus 1 over cube root of x equal to 0. Now, if you have to bring this one over, that means this one has to be equal to 0, so cube root of x squared now becomes 1 over cube root of x. Then by cross multiplication, we end up getting x equals simply 1. Now, then here, that's basically the borderline. Then what's actually happening? And another thing is this, as you can see, when x is equal to 0, the derivative will not be existing, so therefore when you do the number line, we have 0, we have 1, and then therefore we have 3 sections. Now, when you look into this one, this essentially is the f prime right here. So let us say if we have negative numbers, such as negative 1 seems to be nice. And when you plug in negative 1 here, then we end up getting 10 over 3 times negative 1 squared becomes positive 1 minus 1 over negative 1. That's what we end up getting. In fact, this becomes positive. So we have this one is positive right here. Now, how about the middle section? We can plug in maybe how about 1 over 8 seems to be nice because of the cube root here. And when you plug in 1 over 8, here we have 10 over 3, same thing, positive. If you plug in 1 over 8 into this one, you will end up getting this cube root of 1 over 64. Now minus, here we have cube root of 1 over 64. Now, then this essentially becomes 1 over 4 minus 1 over 8, I'm sorry, here. 2, so we end up getting negative. So here we have negative Likewise, if you plug in a value here, then you will end up getting positive here. So we are looking at two sections, which means this is true, and when x is greater than 1, which is this is true. So 1 and 3, 1 and 3, which is that would be our answer. All right, now this portion is our calculator portion. So whenever it's necessary, I like to use Wolfram, since I don't have calculator with me right now. Now, which of the following choices are true? So when as x approaches 1, which means right here, is the function approaching -1? No, in fact, the function is approaching -2. So that's not it. How about here? This, in fact, expression is derivative of f when x equals 2. So let's look at it when x equals 2. What's the derivative? It seems like the derivative seems to be about 2. So that is okay. How about here? When as the x approaches -1, from the right side, it is in fact approaching one value, 1. But f of -3 is, that is still equal to 1, so that is also okay. So second and third one only. Choice D. Alright. Now, the next question. So this is what we have on this interval. Instantaneous rate of change for f is greater than instantaneous rate of change on g for which of the following value. Now, so we here, then derivative, that's what instantaneous rate of change is, f prime, so it becomes 2 times sine of x, and then multiplied by cosine of x. That's what we end up getting for the second one here. G prime becomes 2 comes up, and then we end up getting simply x. So here, the fact that this one has been greater than this one, how are we going to do that? Value going right here. So we have 2 times cosine x has to be greater than x. When is it? So we realize around here. So that's when it's greater at this particular point. Now, alright, it seems like it should keep on calculating here. That value, if this one is 2, that value seems to be around 1-ish, right? Now, so here, so it seems to be around here, around 1. Alright, now, next question. Given this function, for what values of a and b is this portion, function f is greater than function g. Now, since I don't have calculator, I'm going to try to bring the calculator and try to work on this question and on the next video. Thank you.